Completing the square, section 6.5.
With Brett Holmberg.
And Parker Bigelow. One method for converting a standard from form to vertical form is called completing the square. Remember that 6 plus h squared equals x squared. The trinomial x squared plus 2hx plus h squared is called a perfect square trinomial because it has the square of a binomial. At the right, you can see a binomial. You can, we can cut that out. That x squared plus 2hx plus h squared is the area of a square with the side length of x plus h.
So to find the area of this square, we will multiply these. It's kind of like that method of multiplying, lattice method, but now it is to complete the square. So you do x times h, which is hx, and you do h times h, which is h squared. Then you do x times x, which is x squared, and h times x, which is hx. So now you put this together, and you have x squared plus h squared plus 2hx. And that is how you completed that square.
Forming the perfect square. So, now we are going to find the missing number in a perfect square. And I'd like you to tell me what to put in.
Whoops.
We have 3 and x. And then we have x and 3. 3x, x squared, the missing number, and 3x. The area equals x squared plus 6x plus the missing number.
Now, what would go in there? What would go in there is 9, because 3 times 3 equals 9. And you got x squared because x squared is here, and you got 6x because 3x plus 3x equals 6x. So then you put 9 to complete the square. Doing the square is fun.
The perfect square. Sponsored by Subway. Changing vertex form to standard form. All right. Solve for y and then expand.
Equals.
The equation is y minus k equals a x minus h squared.
Now you add k to each side.
Square the binomial and use the distributive property to distribute to the rest of the equation.
Plus k. Now you square the binomial, and you're going to use the distributive property.
This is in standard form with b equals negative 2 ah and c equals ah squared plus k.
This is in standard form because the degrees go down. Because this is a degree of 2, 3, or 1, 2, and 1. And that is how you change vertex form to standard form.
Sponsored by Subway.
D.
Expanding the binomial.
Alright, Parker, what do I do here?
Add 16 to both sides.
Ah, all right. So I've added 16 to both sides. What's my next step, Parker?
Expand the binomial square.
Perfect. So I expanded the binomial square. You do that by doing x minus 5 times x minus 5. And you do x squared minus 5x minus 5x or plus 25. Then you add your like terms and you put it there. So you expand your binomial square now.
All right.
Now what do you do, Parker?
Distribute the 3.
Ah, so we distributed the 3 from right here to each one of them. And we got y equals 3x squared minus 30x plus 75 plus 16. Now what do we do?
I get it now. Combined like terms.
Spot on. So we combined our like terms, which was our 75 and our 16, and we got 91. So, to wrap this up,
So the original equation is equivalent to one of the standard form with a equals 3 and 6 equals negative 30. A b equals negative 30 and 6 equals 91.
so
That was easy.
So, A is our 3 here, B is our negative 30 here, and C is our 91.
It makes so much more sense now.
And that is our expanding the binomials. Featured by someone.
Sponsored by Subway.